What's up, everyone? Welcome back to another episode's Introduction to Python with PyData Sri Lanka. And what we are going to be discussing through this video is going to be on exception handling. So before we jump into code, let's try to understand what exception handling is all about. So there are two types of errors in Python. One is what we call as a syntax error, and the other one is what we call as exceptions. A syntax error is something that happens prior to the execution of the program. So in the interpreting level, this particular error will be detected and then Python will throw out an error. So usually syntax errors happens when you don't follow the set of rules that is attached with any sort of a programming language. So if you are dealing with Python, if you are not adhering to the set of rules that is attached with Python, there will be a syntax error. For an example, if you look at this particular diagram, you realize that this print statement is lacking a parenthesis at the very end. Because of it, there is going to be a syntax error simply because Python says if you open a parenthesis, you need to close it at some point. Okay. Next set of errors is what we call as exceptions. So exceptions usually happens during the runtime, not prior to the execution. So we have already executed, and when Python comes up with something that it cannot deal with, then there will be an exception thrown. For an example, if we ask Python to divide one or a particular number by zero, Python does not have the ability to kind of deal with it. So it will raise a zero division error. So likewise, if during the execution process, if there is something that Python is unable to handle, it will throw out an exception. And if you have a proper method to handle it, you don't need to disrupt the flow of your code. And that is where exception handling comes into place. So let's learn about it by a little bit of code. Okay. Right. So let's say that we have a very simple program where we enter an age and then the program will spit out the year that we were born in. Okay, assuming that the year currently is 2024. So let's say that we run this particular program and then it's going to say, please enter your age. So I'm going to say that I'm 26. And if I run it, it will spit out, okay, look, if you're 26 now, the year that you were born in is 1998. Now, there is no issue in this particular execution process simply because it was expecting an integer and I provided it with an integer. But what if we run this again and what if I enter a non-integer value? For an example, when they ask you what is my age, I say name, which is a string. And then what happens is when you execute it, Python does not know how to handle it, how to convert a string into an integer, and that's what happens is it's going to throw an exception. Now, when you don't have a proper way to handle this exception, it's going to disrupt the entire flow of the program. So when you come across unexpected errors, a very good example for this is if you have an API and if you're calling data to an API, and in an instance when the data is not there, what happens is now Python is trying to get data and there is no data, and thus there's going to be an exception. And when that happens, it will disrupt the flow if you don't have a proper exception handling process. So, why exception handling comes into place is simply to make sure that we could write a retry logic if the data was not there in that API to handle and manage the flow of the program without disruption in a situation where there was an exception thrown. Okay, so how do we do this? Let's learn. So a very easy way to handle this is you put a try except block. So you put try, okay, here, which is going to indicate to Python saying, look, you need to initially try this. If there is an error, please let me know. So I'm going to say there was an error. Please handle it. So this is just a ordinary message that we are going to be throwing, basically to explain to you guys that when there is an error, this is going to be printed. You can write whatever the logic that you want within this except block. So if you run this, okay, initially they're going to be asking for our age. So let's do the correct version of it. So I say 28 now, and they say, okay, you were born in 1998. So initially it will execute this. And if there is no error, then it will flow as it is. But imagine if there is an error, right? So here again, I'm going to be typing name. What happens is, instead of having this entire trace back, okay, we have handled it because it has printed whatever that is there in this except block. So it has executed whatever there is in this except block. So another thing that we can do is, let's say to handle this properly, we could say, look, if there was an error, you could say uh, print please enter valid value, and then you're saying, okay, enter your age, which should be an integer, just to let the user know, okay, this is what is required. And thus when you run this, and in the initial case, if I say name, it is going to say please enter a valid value, enter your age, which should be an integer, and then you would say 28, and then it will spit it out. So basically, when there was an error, instead of disrupting the entire flow, we managed to somehow manage it with this except block. So that is where a try except or exception handling comes into play. So let's explore even further about exception handling with other keywords that is involved in exception handling in Python. Right. So another thing to note is that you can have as much except blocks as you want. So for each of these errors that is going to be thrown, we can have a separate exception block that can handle that specific error. So we can dedicate a except block for a specific error. So let's explore. So let's say that if we do enter a value that is not an integer, that's going to actually throw what we call as a value error. So how you handle it is, you can add a value error exception as E, and then you can say print there was an error, and that particular error was E. Okay, so when you do this, what it is going to be doing is, if the error that was raised from this particular block was a valid error, this particular code is going to be executed simply because this except block is dedicated to handle value errors, and this is dedicated to handle any other error that is not a value error. So if you execute this again, and let's say I type name, what it's going to be executing is not this particular except block, but not this particular except block, but this, because this is a value error that is being passed. Okay, so likewise, let's say that you can have zero division errors as well. You can have an except block that can handle zero division errors. Okay, so let's say print f string, this is zero division error, and what we will be printing is something like this. So let's say let's just change this a little bit. I'm not just going to do print the age. I'm also going to be dividing 100 by the age, right? It's just for the sake of it. So if we were to run this again, and if I enter a name, that is going to be executing, that's going to be handled from this value error block, and that is what is said here. But imagine now I'm going to run this again, and I'm going to say what's your age, and I'm going to say 0. Now that is not handled by this because that was not a value error. It is, I mean, 0 is an integer, but it was actually a 0 division error, so that was handled by this particular except block. So similarly, you can write as much except blocks as you want, and then if you and for each of these except block you can dedicate it for specific error. Even either you can use an error that is inbuilt, or you can even write custom errors, custom exceptions, which we learn in the next steps, um, and dedicate that except block to handle that particular error. And if there is an error that is not being handled by any of these dedicated except block, it will go to the final except block. So you can have as many except blocks as you want. Right. So the other thing is there is two other keywords that is attached with a try and except blocks. So you have the try, then you have the except, and the other two keywords are else and finally. So let's try to explore what these particular keywords actually means. So if you have, let's say for an example, we had else here. What it will do is let's print this. This was the else block, and let's try to execute and explore what exactly happens. So if you run this, and if I write the correct value, so I say 29, then what happens is this is going to say the year you were born in is 1995, and it's going to divide 100 by 29, and then it's going to print this was the else block. So if you think about it, what is actually happening is if there was no error, this particular block is going to be executed. Okay, so let's see what happens if there was an error. So I say name, and then what happens is there was an error which was an invalid, which is basically the this particular line of code being executed. So what you have to notice is simply because there was an error, this else statement was not executed. So where do we use the else statements is when we have a particular code that we are trying to execute within the try block. And if there was no error, if you want to do something else, then we can use the else block. So we want them to initially try this. If there was an error, then we want them to handle it. If there was no error, then we can execute something else using this else keyword. And the final one is the final keyword is finally. So if you have finally, let's say print, this is what finally, right? We save it, and if we run this, let's initially type a correct value, so 28, and what it says is you were born in 1996, this was executed, this was executed, this was the else block, which means this was executed simply because there was no error, and then finally was also executed. This is what happened finally. Okay, let's just move this space. What if there was an error, right? So let's say that I put name again. Now what happens is this particular error was handled by this exception block, and yet again finally the print statement within finally was printed. So to summarize, finally is used in a situation disregard of whether there was an error or not. If they want to execute some sort of a code, then you can use the finally keyword, and within that block you can write whatever that you want. So this is very useful in situations when you open a particular file, and if there was an error or not, if you want to close it, then you can use the finally keyword. So to summarize the set of keywords, you can use as much except blocks, and you can specify a specific error so that it will be a dedicated except block to handle that specific error. Then you can also use else statement, which is only being executed if there was no error. And then you have the finally keyword, which is a block which will be executed disregard of whether there was an error or not. Okay, let's look at an example where this can be used in a general, in a much more systematic context. Right, so let's look at an example where exceptions and tries and finalies is used in a real life context. So let's say that I want to open a file called demofile.txt. So this particular file is located in here, and let's remove what is there. And now it's an empty file. And what I want to do is simply, I want to open the file, then I want to write this particular word in lorem ipsum, and then if there was no error, I wanted to close the file. So as you can see, this is actually a nested try except block. So initially, if there was an issue when trying to open this file, then this particular except block will be executed. If it successfully opens it, and then if there was an error when trying to write this particular wording into this file, then this particular except block will be executed. Okay, but finally will only be executed if we manage to open this particular file. Right, so let's try to execute this. When we execute it, we'll see that something went wrong when writing, and then it closed this open file. So we tried to open this, and there was something that went wrong, which is we opened it successfully. Then when we were trying to write, this was printed because there was an issue when trying to write. So the reason for that is because this was actually opened as a read-only file. So we need to add a W to state to Python, look, this is not just a read-only file, but as a write. We also granted the writing rights. So here, when you run this now, you will see there was no error. We managed to open it. We wrote something, and then finally the file was closed, and this particular line of code was printed. So if you go to demo file, you will see that it was initially empty, but now something has been printed. So let's now try to trigger. Now we triggered this, right? Let's try to trigger this. So let's say that I am going to specify a path which is not available. I'm going to say final um, final, and I'm going to save it, and I'm going to run. Now this is not a path that exists. So when you try to run this, it will say something went wrong when opening the file. So this is where exactly things can be used when it comes to these try except blocks. So you can have a exception to handle if the particular file was not available. Also, you can also have an try except block within that try block to handle a situation where you are trying to do something to the open file and there was some sort of an error. Okay, cool. So there is also the possibility to use the raise statement to raise an exception if there was a specific condition that was not met. So except blocks will be usually executed when Python identified something that they cannot handle. But imagine you know for a fact that, okay, there is this particular issue that might come across, and because of it, if that occurs, then we need to stop it from going further. Then we can use the raise statement. So for an example, if your program is expecting integers, and if you send in a string, then there will be an exception that is going to be thrown because Python does not know how to handle it. But imagine you want to make sure that the values that are going to be coming should always be positive values, something that is greater than 0. But this is not something that you can specify within an except block, because Python will not have a problem in handling negative numbers and positive numbers. So in such a situation, you can use a conditional statement, and then you can use this raise block, and then you can specify an exception, and within this exception always realize the first argument that it takes is the message that you want to print out or to throw out with the exception. And once you do this, if you run this, you will see that there was an exception that was thrown, say exception, sorry, value is below 0. So now this is where we have specifically stated a condition, and then we have thrown an error. So this is very useful in situations where we are writing custom exceptions, which is exceptions that are being created by us to be thrown at a specific situation. So something that is not something that Python cannot handle, but it's something that we want to avoid, um, and we want to avoid within the flow of our program. So let's say that I change this to 2, and if I save this and run it, this will be executed. So by specifying a specific condition, we can also raise exceptions. Let's look at another quick example of a situation where we use both raise and accept blocks. So let's say that we have this particular function called play tutorial, and it's going to take in some sort of a string value. Let's say string. Okay. And this particular string value, if it is equal to this particular string, then it's going to print this. If it is equal to this, then it's going to print this. If for some reason it is neither equal to this or this, then we are going to raise saying tutorial video not found. Okay. On top of that, we also have an except block that is dedicated, saying except value error as VE, which is going to be handling value errors, as well as we have another expect block which is going to handle all the other errors that is not a value error. Okay. So let's run this particular function. Initially I'm going to say I'm going to try and um, input this particular value, and if I save this and if I run this, what it will print is plain tutorial video exception handling, which is what this is executing this. What if I say just Python tutorial? Okay, if I say just Python tutorial and if I run this, what it has done is it has raised a value where I say tutorial video not found. What if I send, okay, what if I send 2 here, right? What if I send 2 here? What it will say is again tutorial video not found because that is not found. Okay, so this is where we can use try except blocks to kind of handle errors. On top of that, where we can use the raise statement to make sure that if the specific condition was not met, we also raise an exception in that case, basically indicating that it is going to disrupt the flow of your system. Now let's look into another interesting area in Python exception handling, which is building our own custom exception. So how do we do this? Simply, what you need to do is you will need to define a class with the name of the exception that you're trying to handle. So in this case, I'm going to name the exception as invalid age exception, and I'm going to inherit exception a module, which is the inbuilt exception handling module within Python. And then I'm not going to do anything. I'm just going to say pass. Okay, so again, to repeat myself, you need to define a class, and this within this class you will have to specify what that the name of the exception, and then you have to inherit exception from the exception module. So what we're going to be doing in this particular code is we're going to take in an input, an age, and we are going to check if it is greater than or less than the less than 18. If it is less than 18, then we are going to raise an invalid age exception. If it is not, then we are going to say you can get a driver's license. And if it was not an integer but something else, then we are going to be raising a value error. So if you run this, it's going to ask for your age. So I'm going to say I am 20. 20. If I say 20, it's going to say you can get a driver's license. But if I say I am 17, what it is going to do is it's going to raise an invalid age exception, and that is what has happened here. So since I mentioned earlier, exception modules first argument is the message that you want to print, and since invalidated age exception is inheriting everything from exception, you can add a parenthesis and then pass um, you have you haven't reached the correct age, which will be used as the message to print with when the invalid age exception is raised. So if I was to run this, and if I was to say 17, it will raise that, and it will also say invalid age exception, you haven't reached the correct age. Okay, so that's the simplest way of creating your own exceptions. Let's try to explore a little further about how to kind of modify these exceptions, custom exceptions that you build. Okay, sure. Let's explore a little further in how to kind of modernize or customize your own custom exception. So first things first, you need to build your class, which and you need to name your exception. And I'm going to name mine as salary not in range error, and I'm going to inherit the exception parent class to this particular class. Then within the constructor or the init method, I'm going to pass in two arguments. One is salary and the other one is going to be message. And this message is going to have some sort of a default value. I'm going to initiate salary and also the message, and the message is going to contain both the message and another f string which is going to be attached in the salary here. The salary is this much. Okay, and now my custom exception block is complete. Now I'm going to be I'm going to request for an input. And if that salary is not between this particular range, I'm going to raise that particular error. So as I mentioned earlier, raise can be used to raise our custom exceptions by specifying a condition. So let's run this. They ask for a salary, so I'm going to say 2,500. And what it is going to mention is, look, salary is not in range, salary is not in range. They have raised the exception, salary not in range error, and it has printed the salary not in range message. The salary is 2,500. Okay, so here what has happened is I have passed salary, but I have not passed a message. So because of it, the default value has been picked up. What if I do pass a message like this? Right? What happens when I do pass a message? It's going to override this particular value and then it's going to use this. So let's run this again, and I'm going to say 2560 this time, just 60 more. And then what it's going to use is going to raise that error, and it's going to say salary should be between 5,000 and 10,000. The salary is 2,500, 560. So that is how you kind of modify your own custom exception block to kind of throw an error based on your own requirement. Okay, so in the initial situation, we only had the opportunity to pass the message because we didn't specify anything interesting here. We're just going to pass it. I'm just going to inherit this and then going to use it as it is. But in this case, we have initiated our own constructor, and to this we're going to be taking two inputs, and based on these two inputs we're going to be generating a very custom message that we're going to be outputting to the terminal. Okay, let's try to look at a final example where we can also write a message by overriding the dunder method string within the exception class. So what we're going to be doing here is we're going to create an exception called metal strength error, where we're going to try and see if the metal strength is meeting the required amount. We're going to set the minimum strength to be 100, which is going to be in megapascals, and the maximum to be in 500. So we're going to initiate it using our constructor, and we are going to be passing the strength into this particular constructor, and all the other arguments will also be initiated. But something different from the previous thing was is going to be that we are going to be overriding this string dunder method, where where we're going to be stating, look, if there was an error, this is the error that you need to print. The metal strength, you take the strength, is not within the minimum and the maximum MPAs. Okay, so if you were to, let's say now the example is that we're going to state it as 600, and if the metal strength dot error, which is this particular variable, is if the metal strength is greater than this or less than this, then it's going to be fine. But if it is not, then we are going to be raising the error. Okay, so if you were to execute this, you will see that since it is 600 and since it is not between these two values. It has raised metal strength. The metal strength is 600 MPs, is not within the valid range of. So instead of doing this, where we're going to be overriding the message instant variable, we have overwritten the string dunder method to do the same thing as what we did here. But you can use both of them to kind of customize your own exception. Right. So what we learned today is how to handle exceptions within Python. We learned about the 4 keywords and how we can also write exceptions that are dedicated to handle a specific error. Then we discussed about building our own custom exceptions, how to override the messages, both using the constructor and the instant variable, or by the string dunder method. So that's it for this video. Hope you join in our future videos as well, where we try to explore the possibilities in Python. Thank you and cheers.